Hello, today we're going to talk about intercepts and line of symmetry, and then we're going to talk about minimums and maximums and increasing and decreasing. It's going to be in a three-part series, so there'll be 3 different videos. The first part is going to be intercepts and lines of symmetry. Intercept is where it crosses the axis. X-intercept is where the graph crosses the x-axis, and then it should be written as the ordered pair of whatever that value is for x and 0, because if it's touching the y-axis, y is always going to be 0. A y-intercept is where the graph crosses the y-axis, and that point should be written as an ordered pair of 0, y, because the y-axis is where x is 0. So x is always going to be 0, and then where it's crossing the y-axis, that's what y is going to be. It is very possible to have a minimum of 0 intercepts, and it is also possible to have more than one intercept, depending on how many times the line is crossing. And if you have a parabola, it's very possible to cross more than once. So we're going to take a look at a couple. We're going to find the x and y intercepts of the following graphs. And so when I look at this first one, and I look to see where it's crossing the x-axis, well, this is my x-axis, and it is not crossing the x-axis at all. So there are no x-intercepts. So an x-intercept is none. However, it is crossing the y-axis. It's crossing it right here at 1. And so the y-intercept is going to be where x is 0 and y is 1. And so that is the y-intercept of this graph. When I look at this one, I see that it's a wavy line. And one of the first things I notice is that it's crossing the x-axis at 3 points. So it has 3 x-intercepts. So the first one would be at, well, let's call this A. So at A0, and at 0, 0, and again, and let's call this one B, at B0. When I look for the y-intercept, is it crossing the y-intercept or y-axis at all? And it is, but only at this point. So the y-intercept is going to be at 0, 0, and that is the only one that it's showing. So it's the only one that we can record. When I take a look at this one, it's a V shape, and I'm looking for x-intercepts, and I see that it's crossing twice. That's at -1, and again here at 1, 2, 3. So my x-intercepts are at -1, 0, and at 3, 0. My y-intercept is only occurring at this point right here at -2, and so my y-intercept, x is 0, and y is at -2. So you see how they can have no intercepts, they can have more than one intercept, or they can only have one intercept. Okay? Lines of symmetry. If you could reflect or flip a figure over a line and the figure appears unchanged, sometimes also called a mirror image, then the figure has a reflection of symmetry or a line of symmetry. The line that you reflect over is called the line of symmetry. And the line of symmetry divides a figure into 2 mirror image halves. And so, let's see, I want to draw a line. And let's make it dotted. I'll make it a little easier to see. So when I take and I look at these, I look for the minimum or the maximum point. So the bottommost point on this one looks to be right here. And so if I were to draw my line straight through it, we notice that my line of symmetry in this case is my y-axis. And so it does have a line of symmetry, and in this case it's the y-axis. When I look at this one and I want to try to determine if I can create a mirror image, one way of doing it is to look for a point where you can flip it. And if I flip that, I don't get a mirror image. If I draw a line here, oh, that's not going to work. Let's move it. There, again, it's not going to be a mirror image. So what's occurring here is that I do not have a line of symmetry. I could even do a horizontal line, and if I take this and I flip it over, it's not going to be exactly the same. It's going to be, it'll be like the opposite. So there is no, so this one has no line of symmetry. When I take a look at this one, this V, my lowest point here, and then I'm going to draw my line through that point. I'm going to draw a vertical line. If I were to organize this a little bit, if I were to flip this side over, it would match up directly with this. It's like a mirror image of itself. And so this one does have a line of symmetry. It's this point right here. Okay, so when I looked at these, my first one had a line of symmetry. My second one had a line of symmetry. Or, sorry, the second one did not have a line of symmetry, and the third one did. Okay. You have a practice work in your guided notes packet that I would like you to work on for homework today. It's going to be super easy. If you have any questions, come see me.